Diving into the corals brings me absolute joy and happiness. Falling in love with the underwater world while diving, I realized that it's also a very fragile environment. Lots of threats, for example, from climate change, direct human impact, overfishing, or pollution itself. Corals play an immensely important role for the ecosystem, the health of the ocean, and for us humans as well. They provide all sorts of environmental services, such as shoreline protection, a refuge for loads of animals, for biodiversity, food security, and also income for the tourism industry. The restoration part is feasible and important because some areas, after they have been degraded, have a hard time to recover by themselves. And that's where it makes sense to initiate a healing process to bring back the coral as it was maybe 10, 15, 20 years ago. When we do coral restoration, we apply the mineral accretion technology, which means we place structures out of metal in the ocean, attach small fragments of coral onto them, and run a small amount of electricity through it. This has the effect of supporting the corals that are growing on these structures with higher speed of growth, better resilience, and also survival rate in times of stress. Once the restoration process is initiated, it actually goes pretty quick until life comes back. And that's a very important factor also for me personally, to see that there is a lot of hope that we can bring back the coral reefs that have been destroyed if we give nature a break. But if you want to protect the natural environment, you have to understand the diversity of marine life and the geological conditions. As part of this, we were able to bring in Diego and Ander from BlueNomads. They have the knowledge to survey the ocean floor with the technology of side-scan sonar, 3D interferometry, and photogrammetry scanning. The side-scan sonar is an acoustic-based technology. Its high-resolution imagery can be stitched together to build a complete mosaic picture of the ocean floor in large scale. Photogrammetry goes into extreme details by creating 3D imagery of the ocean floor. This makes it very easy to identify and also classify, for example, coral species, benthic life, and all sorts of living organisms on the seabed. Once the data is collected, you can create two-dimensional or three-dimensional underwater maps. Therefore, you can have a profound understanding, for example, of the diversity of life. And this, again, can be used to push forward, for example, legislations to create marine protected areas. The oceans have a tough time at the moment, but I truly believe that if we all come together in a joint effort, we can make the ocean a better place again.